Alright, so as it stands, the equation that we have right now, not very helpful for actually graphing this parabola. What we need to do is we need to transform this equation into something that's in our familiar vertex form so that we know how it compares to our familiar y equals x squared graph, so we can find the vertex, the axis of symmetry, whether or not it's upward or downward facing, and to piece it together. So what we need to do is we're going to have to do some completing of the square here. And so my suggestion is, the first thing I notice is that I've got a coefficient on my x squared. I certainly don't want to have that, so I can complete the square. And my strategy is to go ahead and factor out that 2, but I'm going to factor it out of only the first 2 of my terms in this quadratic. So all I've done is factored out the 2 from these 2 terms, 2 times the quantity of x squared minus 6x. Now, of course, it's time to complete the square here, so let's go ahead and do that. So y equals 2 times the quantity of x squared minus 6x. Now I need to add a 9 in order to complete this square. I still got this 10 from before. And what we need to decide now is, well, how am I going to actually balance this equation, right? If I've obviously done something to this side of the equation, I got to make sure that I keep it true. Well, here's my claim. If we were to actually multiply this 2 through, here's what I claim we'd have. I think we'd have y equals our 2x squared, that's the same as in our original. And I think we'd have minus 12x, that's the same as our original. We definitely have our 10 left over from before, so that's the same. But I think we would have a plus 18. And so, I need to make sure that whatever I end up with down here, this has got to be the exact same as that original equation so that it's still balanced, the equation. So I think I'm going to have to subtract 18 in this case. So I claim that in this step up here, in order to balance this equation, I need to subtract an 18, which, note, is the same as 2 times 9. We've effectively added 2 times 9, so we must also subtract 2 times 9. Alright, so now, I'm going to go ahead and get rid of this down here. So now I think we're ready to write this as, well, y equals 2 times the quantity of, well, what's really beautiful is here's our x minus 3 quantity squared, and these two will add to negative 8. Alright, we've got it in vertex form, we're ready to go. I think the vertex of this parabola is going to be 3 comma negative 8. And I think the axis of symmetry is going to be the vertical line x equals 3. I strongly suggest actually going ahead and graphing your axis of symmetry all the time. I find it really helpful for piecing together my graphs. It's just nice to see it. I'm just going to make that a little bit more accurate. Awesome. Our y-intercept of this graph, the only thing that our standard form is actually good for is finding our y-intercept right there. So we got a y-intercept of positive 10. I'm going to go ahead and graph that in red. And what's really nice is if I have that y-intercept 3 units to the left of my axis of symmetry, I'm certainly going to have one 3 units to the right as well. Let's go ahead and find our x-intercepts. We've got some options here. Per usual, we're just going to set our y value equal to 0 and solve for x. So I'm going to do that in maroon here. So our x-intercepts, we're going to go ahead and set y equal to 0 and just solve this equation. So I'm going to add 8 to both sides. I'm then going to subtract, I'm going to divide both sides by 2. 4 equals x minus 3 quantity squared. When I take the square root of both sides, now 4 is a really nice number, I'm going to get some nice x-intercepts here. Plus or minus 2 equals x minus 3. If I add 3 to both sides, I think our x-intercepts are going to be 3 plus 2 and 3 minus 2. So 5 and 1 in this case. I'm going to go ahead and graph those. Here's one of them. 2 units to the right, and there's another one, 2 units to the left of our axis of symmetry. And you know what, I got to be honest, I think we're pretty much ready to go ahead and graph, so I'm going to go ahead and sketch the graph right now. And there is our graph of y equals 2x squared minus 12x plus 10. Note to self, we got some really nice x-intercepts this time, which means we could have originally factored our quadratic. Are we always going to be able to factor? Nope. But in this case, we were able to. And you can see that after factoring out that common factor of 2, x minus 5, x minus 1, our x-intercepts are definitely going to be 5 and 1 if we were to set y equal to 0. All right.